we are going to see many more capabilities. We're going to see the rise of agentic systems. We're going to see agentic robots taking imitation learning and actually running fine-tuning in production. We are in a phase of continuing fast change.
James, thank you for coming here and having a conversation with me. It's so nice to have you here.
I'm super excited to be here. I love talking about AI and physical AI, so I'm enthused.
And this is the right place to talk about it because we're in the middle of robots walking down a hall, AI all over the place, and I still haven't figured out what's the difference between digital AI and physical AI.
That's a great question, and to me, I like to kind of think about this through kind of a physics metaphor or analogy, and to me, it's like the acoustics. And so to me, when I look at this space, and specifically digital AI, I think of it as a high density, high stiffness medium. And I think of physical AI is low density, low stiffness. And let me explain.
You're going real geek on me here.
I am a geek though, I am a geek. Okay. That's what I am. So acoustics is very interesting. So a high density, high stiffness, sound travels through very quickly, and there's almost no absorption. And I think we see this in the digital space right now. AI adoption is super fast, it spreads over everything, and there's these echoing, and it gets everywhere. There's no absorption in the space, and it's beautiful to see this because everything is happening so quickly. Physical AI is a little bit different. It's lower density, lower stiffness, and what happens is sound travels more slowly through this medium. Sound is absorbed in this medium. And I think that this is the contrast that is relevant as we look at what maybe some will say is the slower adoption rate or the complexity of deploying in the physical AI world versus the digital AI.
I see why you would say this. At the same time, we do have robots walking around halls of Hannover Messe. That's not a sound through the sponge. This is definitely faster than that.
It's true, but I think we are at the early stages of that. How many of these humanoids are deployed in industrial settings? And it's not about the speed of innovation, it's the speed of adoption.
And there was also, I always get confused about this one, because when I see a robot, I'm thinking AI, but it's not true. Robot is just a bunch of mechanical parts moving around. There's no intelligence in that object.
I mean, there's no AI, but there's a lot of intelligence within that.
Okay. Tell me why.
I mean, a lot of design principles went into that. Motion planning was a very complex optimization problem. Intelligence, not artificial intelligence.
But you're right, because there's actually a lot of complexity there, and complexity that does something that requires
AI. Now we're going forward. So a lot of these systems were built and they were relatively rigid. And I think this goes to what we have seen historically as the adoption of robotics, and where I think physical AI will hasten that adoption, broaden that adoption. And so if you look classically, robotics is not a youngling. It's like a retiree now. It's over 60 years old. It's been around for longer than most people think.
I was excited about robotics when I was in high school, and that was many, many, many years ago. Yes, it's a very old concept.
And so it's been around, and so why isn't it so universal today? Well, I think we saw waves of adoption. The first wave went into high volume manufacturing, where the cost of the integration made sense because it was very hard and it was open loop and had to be precise, and you designed a lot of processes to make sure it would work. That was the first stage.
And fragile.
Extremely fragile. And so a lot of design effort went into accommodating the automation and the robotics. I think we are exiting the second phase, and the second phase was kind of the innovation of easier to program, really stretching into higher mix situations, going to SMEs and not just these huge automation companies.
Were you including cobots in that phase?
Precisely. I think cobots are the exemplar for that phase. Cobot was safe to use around humans, but it was also much, much easier to program, had a much higher user friendliness. You didn't need to do ladder logic and spend all of this time.
So it's not just how they behave, but how you interacted with them as a developer, of somebody who
A lot of the time goes into the actual integration. And I think this is going now to where physical AI can help in the third wave, so to speak. And I think that AI can help on the integration itself, AI discovery of the parts, because a lot of it goes into understanding what the equipment is, how to interact with the equipment.
But give me one more. I'm still struggling with my own definitions here.
Sure.
Physical AI,
Yes.
robotics.
Yes.
Same, different,
Overlapping. I would say it's the physical AI is the
substrate?
or I guess robotics is the substrate that physical AI is being applied to.
Okay. Now, the new phase.
Yes.
How far did we get into it?
I think that this is also maybe reconnecting to that digital AI. We're a beneficiary of all of the hyper fast development cycles that have been happening there. And specifically looking at foundation models, even some of the efforts in agentic systems, I think we're going to start seeing that transfer over. Now, how far have we gotten? We have amazing humanoid robots trained with reinforcement learning and simulation that can now do kung fu moves on the floor.
Yeah.
Right. So I think we're starting to see this adaptation happening, but we still have the longer effort of the sales cycle, deployment and integration, getting on customer site, and then them scaling up their deployment, because usually you start with one robot or a small number, and then you figure out to scale, and then you broaden. So I think that we have real dynamics in the system we have to just operate.
Is there a commercial value in this yet, or is it all just people having fun and playing?
No, I think there is commercial value.
Already in the third phase?
Yes, I think there already is. I think that one of the places that we are starting to see is in resiliency. One of the big difficulties, at least in existing applications, is resiliency. The robots have not been as reliable as we wanted them to be. And that was, I think, due a lot to the rigidity of the software that they were running on. And so we couldn't program our way or code our way out of all of the edge cases and everything else. And so reliability has been really one of the big blockers. We started with, it's performant, and now it's reliability. And I think that we have an opportunity, or we're seeing that the resiliency from the adaptability, the generalization that we can get from AI, which is almost paradoxical to most people's belief, may actually help with is helping with the resiliency and performance of the systems. Sure. There's a great example we see all the time. You see these physical AI solutions, these foundation models will go to try to perform a task, maybe like picking up this. And if they kind of fail the first time, what do? They retry, right? And so maybe the individual success rate is only 95, 97%, but when you encapsulate that into a solution that is going through these resiliency retry behaviors, suddenly the success rate goes up.
So it's a completely different type of behavior, because you have not exactly an emergent behavior, but getting close to that idea that you are. It's not a moment in time for which you are perfecting. It's a series that you are now
that's precisely
optimizing
correct.
for.
That's right.
The other thing so I'm going to just use you as my Wikipedia here. When I think about robotics, I think as much about the physical movements of the robot, the sensors, actuators, the things that make it move, as I think about the intelligence that runs it. When you talk about it, I can see you shifting towards the programming, the intelligence. Do you not care about the physical component of it?
Of course I do. And I think this is actually, again, when we go back to the cost of integration or development of a solution, most of the integration time is spent there, trying to get all of these sensors, all of the components to actually work together, optimizing the motions of the arms. This is a huge chunk, and I think there's an opportunity for AI there too, to actually help with the discovery in the integration of the equipment itself, which will drastically shorten the time of developing new solutions. Absolutely. And all of that has to be fed upstream, because at the end of the day, physical AI is a model. It takes sensory and proprioceptive input and produces action output, right?
So, moving us away from the factory floor. Now I'm going to go a little out there for you.
Are we going to the moon? Where are we going?
Kind of. Evolution. Like, we are a system with actuators and sensors, and at some point we were fish.
Yep.
Is that how it happened? How does it compare, the process that we are going with robotics and physical AI? How does it compare to the last 4 billion years of evolution.
Oh, it's much, much faster.
Okay, I buy this one.
But so, I mean, the timescales are so absurd, right? Like 4 billion years of evolution. I think one of the things that's there's analogs. We have been following an evolutionary process, but it's also more than that because evolution is by definition, a different timescale. We're actually adapting within specific cycles, and so there's a lot more complexity, I think, that's happening in this than so. Evolution, like broadly speaking, abusing the analogy all the way, it's much, much faster right now.
How much faster? We are here. Let me give you one more
6.7 million times.
Last year, here, there was almost hardly any robots. There was a couple of companies that were talking about it, all theoretically, mostly theoretically. Today, you can see robots walking around, and pretty much everybody who's displaying anything manufacturing-wise will have an example of some vaguely autonomous system. Are we going to go through another billion years of evolution over the next 12 months? Like, what would it look like next year here?
So, I think the answer to that question is likely yes, caveat asterisk. So, I like to prognosticate, and when I do this, I like to roll out these kind of ensemble paths. And in this process, I think I can roughly categorize 3 different sets of outcomes. So on one outcome, which I don't want to spend a ton of time on, is AI kind of slows down. Like we kind of saturate AI. There's not a lot of more progress.
Well, AI as a concept,
as a concept, like the progress really does slow down. Yep. AI is already useful. It's already useful. I use it every day. I think most people are already using it every day. Even if it slowed down and only got incrementally better, there's already value. And so I think what we'll spend is a little bit more time building scaffolding around the limitations. Mm-hmm. We'll see less penetration, but it's here to stay. Like it's here to stay.
It will still move the physical AI forward.
It will still move physical AI forward. The other extreme is the exponential growth, which leads to artificial superintelligence, ASI. By definition, we can't imagine that because it's a superintelligence and we can't imagine something that's beyond our capabilities. So it's not, I mean, this is a great beer conversation, maybe not a great coffee conversation to go off on that one. But I think the interesting middle one is where I believe, I kind of stake my career on it, is we're going to continue to see progress in AI. Linear, super linear, so that in the midterm, it's going to be substantially more proficient than today. And so I think in the next 12 months, next year, we are going to see many more capabilities. We're going to see the rise of agentic systems. We're going to see agentic robots interacting with agentic orchestrations, interacting with agentic supply chains. This is where we're going to start going. We're going to see robots who are taking imitation learning and actually running fine-tuning in production. So I think we're going to see also some of the things as we trickle through this slow adoption curve. We're going to see the things today, and maybe a stepwise longer, starting to be adopted. But I do think that we are in a phase of continuing fast change.
Right in the middle of it, yeah.
Yes.
The one thing that I didn't ask you is, why are you talking about robotics? Like, how do you know anything about robotics? So maybe we should ask this question. Tell me a little bit about yourself. What do you do, your company?
Sure. I work for Teradyne. Teradyne has been in the semiconductor test space for over 60 years. 15 years ago, Teradyne decided to diversify and moved into robotics with the acquisition of Universal Robots, which does arms, the little blue cap arms that everybody knows and loves. I love them. Hopefully everybody else does too. They since then acquired 4 additional robotics companies and merged them into 2, Universal Robots and Mobile Industrial Robots. And so our portfolio is basically everything from arms to mobile platforms to mobile manipulators, and also recently forked products. So that's Teradyne Robotics.
So you are doing robotics today?
We are doing
with robotics. Real customers, implementations. Okay, got it.
We touch almost every industry, every segment.
Every industry?
Yes. Wait, which one? Okay, we're not in space. We're not on the moon.
But even like we're sitting here. This is manufacturing. I was assuming manufacturing would be the core of it.
Yes.
But retail, CG, like really?
Yeah, we're in retail.
Really?
Yes. Now, most of our our bread and butter is in manufacturing. Logistics comes next, and then it kind of obviously tapers off from there. But yes, we really do see use cases everywhere. In fact, I'll send you some videos later if you want to see all sorts of very interesting use cases where our arms end up in or robots or mobile
This
bots.
is still in context of robots in business environments, not consumer environments, because that's a different story.
Oh, we have robots in consumer environments too.
Tell me about it.
We have robots that are in, when you actually, I'm going to back up a little bit. When you say consumer environment, help me understand, because retail to me
cleaning
is
and ironing would be my understanding of consumer.
So we have retail, we have them working in restaurants, we have them working, perusing malls, we have them all sorts of different places. Yes.
Those robots are getting around.
They are.
It's fascinating, and I can see this coming our way. And you're right, those three scenarios that you outlined for us, I guess we won't know until it happens. And you got to watch this thing.
And I think that's what's fun is with change happening this fast, it's hard to predict, but it's also very exciting time. Like, I'm excited. My whole career has been built around AI, and I can tell you 5 years ago, I did not see where we would be today. And I don't think anybody did.
5 years ago, nobody was even thinking that this is real. 5 years ago, nobody thought AI was real.
I mean, I did, but I mean...
Okay, few people did.
I thought our timelines were longer.
But the physical AI, until this year, I don't think people believed that it's real.
I agree with that. And I think a couple things led to that. People got accustomed to the digital AI. They saw what digital AI was capable of. I think that was one. And so when people are using AI every day, they can themselves transfer the belief that this will work in other spaces. And then I think what you also said is true, is that people walk around here now and see robots doing more. And so I think that is expanding the confidence that this is actually going to be a solution and add value.
And for this area, for manufacturing, I think everything we're talking about, the changes that we're bringing here, I think they become real once physical AI becomes real. Because we are dealing with physical objects here. This is not text, this is machines moving things. So I think the real change that's coming here is physical AI.
I strongly agree with that. Most of our economy relates to the physical goods that we mine, we build, we ship, we use.
A lot of gamers would not agree with you, but I understand where you're coming from.
I do not want to minimize the impact of the digital world at all, but just straight on in our economy, and we're gonna have to fact check this later, but I think the bulk of it actually relates to the production, sale, and use of physical goods.
Well, we are still physical beings, so
until we get ourselves plugged in. Till that happens.
This was fascinating. Thank you for sitting with me and chatting and educating me here. I really appreciate it.
I had a great time. Thank you.
Thank you.